Okay, in this video, what I want to do is I want to take something that's commonly hated and misunderstood, and I think people think it's a lot more complicated than it really is. I want to talk about the quadratic formula, all right? And what I want to do is I want to show you that it didn't just materialize from thin air. It comes from something, and it comes from something that a lot of you have already encountered, and maybe you weren't aware it came from that. And so we are going to take a look at that, okay? So the first thing I want to do is I want to say that if you look at the quadratic formula, and I'm not going to write it out because we're going to come up with it in a minute, it's dealing with quadratic equations, which deal with the form ax squared plus bx plus c, right? And so what we want to be able to do is we want to be able to derive this using, that a and that b and that c, because the quadratic formula says, x equals and then blah, 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 everything that it says, right? So we want to make sure that we're writing this in terms of those three variables and nothing else, all right? And so I was thinking about this, and I'm like, okay, well, how else do you solve equations with quadratics, and how could we maybe blend it into that? And then, and obviously factoring's not going to work, because with factoring, it just gets you down to, a form like this, and that's not going to really do anything. But then I thought, what about completing the square? Okay, so when we complete the square, right? So let's say that we're dealing with this equation, this ax squared plus bx plus c, right? And we're like, okay, and we're assuming, and we're saying it's equal to 0, right? And we want to solve for it, but it's not factorable, and so we decide we're going to complete the square, right? And so we have that whole process that we do with completing the square. And so what I thought is, well, what if I just leave it like this, like don't put any coefficients or anything in it, and completely leave it like this, and then see if we can, manipulate it a little bit and bend some things around and do some things to it, and see if we can come up with the quadratic formula, just to show that it's not just this mystical thing that just, fell from the heavens and, is here now to torture teenagers everywhere. So let's see if we can find it. Okay, so what I'm going to do is, what I do know about completing the square is when your first term, your x squared term, has to have a coefficient, right? And sorry, I'm using a weird stylus, so it doesn't really work very well. It's coefficient of 1, right, is what I need to have. So in order to do that, that means I got to divide by a across everything, okay? Because then that will cancel this out, and that will give me just x squared. So we get x squared plus bx over a plus c over a equals, and we're just going to call that 0, because 0 divided by anything is just 0. That's how 0 rolls. Okay, now we know when we complete the square that we have this process we have to follow. So the first thing we have to do that I teach my kids is move this thing over there. All right, so we're going to have x squared plus bx over a equals negative c over a. All right, next thing we're going to do is we're going to take this b over a x thing, right? And we're gonna deal with this right here. And what we do when we use completing the square is we divide that by 2, right? You divide b by 2, and then you square it, right? And then you add that to both sides of the equation. So I'm going to take this b over a, and instead of dividing it by 2, I'm going to multiply it by 1/2, which is the same thing, right? So we get b over 2a. Looks a lot like my vertex form, doesn't it? Well, that's not a coincidence either, but that's another video. All right, so you got b over 2a, right? And now we're going to square that. So we're going to go b over 2a. Let's square this puppy, okay? And that gives me b squared over 4a squared, okay? So I am going to add that messy looking thing to both sides, all right? So that'll give me b squared over 4a squared plus b squared over 4a squared. All right, that's supposed to be a squared. Let's see if we can clean that up a little bit. That looks a little better. Okay, now let's factor this side. So we're going to get x plus, and then that's b over 2a, right? B over 2a squared, that whole quantity squared, is equal to this mess. All right, and what I'm going to do with this mess is I'm going to get it so that I can work with it, right? And if I'm going to take the square root of this, I'm not going to be able to do anything with this. But if I can write it maybe as a fraction, find a common denominator, right? So I'm going to use 4a squared as my common denominator, right? And so to use 4a squared as my common denominator, this term's good. So we got equals, and we got our b squared over 4a squared. This thing's great. This is exactly what we want. But this, right, in order to get to that, I got to multiply everything by 4a. So both of these got to be multiplied by 4a. So this is going to give me 4ac over 4a squared, right? So now let's add these together, and we get 4ac plus b squared, right, over 4a squared, right? And I forgot something too. And what I forgot is we had that negative sign out there. So this is actually a negative 4ac. So what I'm going to do now is I'm going to rewrite this, right? So we have our negative 4ac plus b squared because this was negative, and I neglected that when I multiplied it out, is I'm going to rewrite this as b squared. So I'm going to put that first and then subtract the 4ac over 4a squared, right? So next step is we're going to take the square root of everything. So I'm going to switch colors here, right? And we're going to go like this. We're going to take the square root of this side, and we're going to take the square root of this side. And then you're going to start to see this thing take shape, right? So we have x plus b over 2a equals plus and minus, and we got our square root of, look at that, b squared minus 4ac, that it would be our discriminant, right, over, and I could write this as the square root of 4a squared, but let's do this off to the side, and you'll see that this is a square number, and it cleans up really nice. It cleans up to 2a, and look at that. Is that not magic or what, right? And so we're going to take this and we're going to move this down a little bit. All right, so now my last step is I have to subtract this to get x by itself. So we're going to subtract b over 2a, and we're going to subtract b over 2a from this side, right? And when I do that, I'm going to now move this in front, right? Because that's how that works. So we go negative b over 2a plus and minus this mess, b squared minus 4ac over 2a. And now they have a common denominator. So let's just put it all together, right? So we got x equals negative b plus and minus the square root of b squared minus 4ac all over the denominator of 2a, and lo and behold, you have just come up with the quadratic formula all on your own. And what I think is important about this is just showing you, first of all, that it just, like I said, and I was being a little sarcastic, but it didn't just come from thin air. It comes from something. Somebody thought, well, hey, what happens if I solve for x? And they figured out that, hey, this is this might be powerful, you know. And anything you use the quadratic formula with, for the most part, you can also use completing the square with, right? They're kind of interchangeable. They're sort of the same thing. The quadratic formula is just nice because if you can remember it, you just pop the numbers in, right? You plug and play. That's all you got to do with it. But well, this shows you how to find it, and I think that's powerful. I do. I think it's very powerful. So I hope you learned something, and I hope you it makes you think about maybe some of the other things that we just tell you got to know about, and maybe where did they come from. All right. So we will. Thanks for watching, and you know, keep being curious. All right.